Assalamu alaikum. Biology and technology began. Cellular glue to generate tissues, heal wounds, regrow nerves. Synthetic molecules that adhere cells could galvanize regenerative medicines. Researchers at UC San Francisco have engineered molecules that act like cellular glue, allowing them to direct in precise fashion how cells bond with each other. The discovery represents a major step toward building tissues and organs along the south goal of generative medicine. At the same molecule are found naturally throughout the body, holding its tens of trillions of cells together in a highly organized pattern. They form structures, create neuronal circuits, and guide immune cells to their targets. Addition also facilitates communication between cells to keep the body functioning as a self-regulating whole. In a new study published in the December 12, 2022 issues of Nature, researchers engineered cells containing customized adhesion molecules that bound with specific partner cells in predictable ways to form complex multicellular ensembles. We were able to engineer cells in a manner that allows us to control which cells they interact with and also to control the nature of that interaction, said senior author Weldon Lim, PhD, the Bayer's distinguished professor of cellular and molecular pharmacology and director of UCGF's and Cell Design Institute. This opens the door to building novel structures like tissues and organs, regenerating connections between cells. Bodily tissues and organs began to form in utero and continue developing through childhood. By adulthood, many of the molecular instructions that guide these generative processes have disappeared, and some tissues, like nerves, cannot heal from injury or disease. Lim hopes to overcome this by engineering alert cells to make new connections, but doing this requires an ability to precise engineer how cells interact with one another. The properties of a tissue, like your skin for example, are determined in large part now the different cells by now the different but now the different cells are organized within its set. Adam Stevens, PhD, the Hart's Fellow in the Cell Design Institute and the first author of the paper, we are devising ways to control these organizations of cells, which is central to being able to synthesize tissues with the properties we want them to have. Much of that makes a given tissue distinct is how tightly its cells are mounted together in a solid organ like a lung or a liver. Many of the cells will be bonded quietly, tightly bound cells of skin or organs tissues to reach a pathogen or the wound. Weaker bonds enable two cells to fight through blood vessels would crawl between the tightly bound cells of skin or organ tissues to reach a pathogen or a wound. To direct the quality of cell bonding, the researchers designed their adhesion molecules in two parts. One part of the molecule acts as a receptor on the outside of the cell and determines which and interact with the second part inside the cell tunes the strength of the bond that forms. The two parts can be mixed and matched in the modular fashion, creating an array of customized cells that bond in different ways across the spectrum of cell types. Thanks for watching my videos. Allah.